We're still working with the coordinate plane for the rest of this week. Today, we're starting to find distance. And along with the distance, we're also going to do some area and perimeter. On page 65 of your workbooks is where we'll start with the notes. We got to jump around a little bit today. But page 65 is where we start off. And what we got there for number one, finding distance in the coordinate plane is just like finding distance on a number line. So what we need to remember is distance is always positive. We can have negative numbers or whatever, but when we're finding the distance between a negative and a positive or two negatives, it's still going to be a positive answer for distance. Distance can be found by plotting the ordered pairs and basically counting the squares from one point to the next. So anytime you graph the points, you can just kind of count how far apart they are. To me, that's not always the easiest way, though. If we go to number two, distance can also be found by eliminating the common number in the ordered pairs and finding the distance between the remaining numbers. So I'll show you that in a second. But for sixth grade math, if we're finding the distance between 2 points, either the x values are going to be the same or the y values will be the same. When you get to 8th grade, then you have to do things a little more complicated, but for 6th grade, not so much. So here's how this works. If you look at that little table there, what you could do is you could graph each one of those points and then just count the squares to find the distance. To me, the easier thing, though, is like the one before just said. We eliminate the common pair. So if we look at point A and point B, the common number is the x value, the 1. So now what we're looking for is the distance between 3 and 7. So how far apart are 3 and 7? 4. So the distance of AB is 4. For point C and D, the second one there, common number is the 2. So we're looking at the distance between -1 and -6. How far is that? 5. If the signs are the same, we basically subtract the absolute value of the numbers. Okay? Third one, points E and F. The 7s are the same, so we eliminate those. And we're going from 2 to -5. A little trickier, maybe. How far apart is 2 and -5? 7. So when the signs are different, like a positive and a negative, that means we're going to add the absolute values. So 2 plus 5 gives us the 7. Same idea for the last one. The 3s are the common number. So we're going from -4 to +5. That's how far? 9. Whoops. Any questions on that? Not so bad, is it? All right, I'm just kind of eliminating the numbers. All right, so at the bottom of that page, you got a couple examples. For the first example, it's showing you You can eliminate the 2. So we're looking for the distance between 3 and -4. So one of the other ways you can do this is also by counting on a number line if you need to. And we got 1, 2, 3, 4, 5, 6, 7. So the answer there would be 7. Do you have to use a number line? No. So go ahead and try that second example and get an answer. Who's got it? 6. Distance between -5 and +1 is 6. So -5, +1. Count each of those spaces in between. We're going up 6. Okay? Any questions? All right, so now we're going to jump ahead. Go to page 162. I didn't make this book, so they don't necessarily put it in order. They put it by the standard or by the topics. So the first part fits in the number systems. Second part now, we're going to geometry. Ordered pairs, they can be used as vertices of polygons. A vertice or vertex, that's basically the corner of a shape. All right, so if I plot 3 points on the graph, I can make a triangle if I connect the dots, right? Same idea, rectangle with 4 points and all that. To draw a polygon, that's what we do. We plot the points in order and connect them. Most of y'all, when you are younger, have done connect the dots. It is important to connect the dots in order, isn't it? If not, you don't get the right picture. Same idea with this. When they give you points, you need to make sure to connect them in order. Each unit is 1 unit of measure. Well, just like we said, counting the squares. For number 4 there, you could be asked to find the missing point, find a perimeter, or to find the area. Perimeter is the measure of the outside of a polygon. How do you find perimeter of a shape? Who remembers? Add up all the sides. Find this by adding all the sides. So if it's a perimeter problem, what we got to do first is find the distance between the points, right? Area, then, is the measure of the inside of a polygon. Perimeter goes around the outside. It's kind of like if you put a fence or a wall around something. Area is filling it in. Squares, rectangles, and parallelograms. Who remembers how to find the area of those? Base times height, that works. Or length times width, you'll sometimes see, especially for the rectangles. Base times height or length times width. Same idea. You get 2 numbers, you multiply them together. Right? What about a triangle? Base times height divided by 2. Sometimes you see it as times 1/2, but to me it's always easier just to divide by 2. So base times height divided by 2. Trapezoid is the trickier one. You basically have to do it in sections, right? First you add the bases. So we normally will see that in parentheses. There's 2 different bases on a trapezoid. So you add them together, multiply by the height, divide by 2. The order can kind of be switched, but you have to add the bases first. If you want to add the bases, divide by 2, and then multiply by the height, that's fine. but added the bases first. Any questions on those? All right, what shape is that? Parallelogram. So parallelogram is base and height. Here's the thing. The numbers that we multiply for triangles and parallelograms, they have to make 90-degree angles. So the way we're going to make a 90-degree angle on this shape, whoops, is by using right there. Okay? So if we count on the left side here, how many squares I got? 3. We count across here, 8. So if we do base times height, it doesn't matter really which one's which. 3 times 8 is? Hey, look at that. There's our answer. Okay? The important part, though, is we do have to have that 90-degree angle when we get the numbers. Everybody clear on that? The one that it matters the most on are when we have parallelograms. Rectangles are easy. They already got the 90-degree angles. All right, so we need a 90-degree angle, right, for a triangle. The way we're going to do this is we want one of the flat sides. We either need a horizontal or vertical side to start with, okay? So if you look, I got a horizontal side right there. That's 7 across. So now I need something that's a 90-degree angle and goes from this side to the opposite end, the opposite point. So that'd be right here. So to make a 90-degree angle, we're going straight up there. That's going to be my height. So for a triangle, we got base times height divided by 2. So 7 times 4 divided by 2. 7 times 4 is 28. 28 divided by 2. And that's our area of the triangle. Again, though, the important part, the part we have to pay attention to, is making the 90-degree angles on those. Okay? Turn the page. I'm pretty sure that's on 163. Right? 163? All right, so that's asking you what shape. Okay, so I'm going to do the first one with green. So what we have to do is we have to plot the points. 2, 4. 2 is the x, so I go over 2, up 4. There's a point. So that's A. B is at 2, 7, so 2, 7. Right there. C is at 5, 7. And D is at 5, 4. So that's right there. We connect the dots in order. What shape did I make? Square. So for shape 1, that is a square. We probably could have figured that out beforehand, too, by looking at the distances. So if we look, AB, I can eliminate the 2's. From 4 to 7 is 3. So that means AB was 3, based on that or by counting. From B to C, this time the 7's are what's the same. So B and C, I can eliminate the 7's. And again, 2 to 5 is 3. And you just kind of do each one by pairs if you're trying to find the area. All right, so shape 2. We've got -3, +4 for point E. That's E right there. F is at 3, 4. So F would be right there. G is at 6, -5. And H is at -6, -5. So what shape do we make right there? Trapezoid. I don't connect the dots necessarily with the straightest lines up here, but yeah, still makes a trapezoid. If you are trying to figure out what the shape is, you kind of need to plot the points so you can see it. In some cases, like the square, find the distance between each side. Could do it for you too, though. Anyone got any questions on that? That graph that was in the books didn't have the numbers or the X and Y axis labeled. When you take your next check-in about a month, or when you take the EOGs, they'll almost always be labeled, or they should always be labeled.